everybody. I appreciate you guys coming out here to the Green Country Hamfest. Today we're going to be talking about an item called M17. And let me make sure my keyboard is reconnected here. Yep. All right. So first of all, out of this entire group, I'm going to ask how many of you guys do digital voice of some sort? AZ System Fusion, DMR, so pretty good group out of the group here. And so that's good. I can tell you several years ago when I asked that question, like 2 people out of 100. It was a very small number of people that were doing digital. So it's glad to see people getting involved with it. Trivia question I'm going to add at the beginning of the presentation. It's going to be a little bit of fun while we're at it too as well here, because the first question that always comes up is, why is the name M17? And I've got some this is like a multiple choice test here, so I've got the answers up, and you decide which one you think is the best answer. So first answer here was, it was created when the founder answered, how many people does it take to stop someone with an M15? The answer is 2, so M15 plus 2 equals M17. Maybe. You don't think so? Okay. It's the name of the newest tank in the Portuguese army, the laser guided M17. You don't think so? Okay. M17 was arrived after modes 1 through 16 were rejected by the ITU.
That's possible.
Sometimes you have to go after that stuff. M17 is the name of a street in Poland. Wrong? You sure that one's wrong? Okay, just want to be sure. This one is taking a little bit of a shot at Mark Klein and Mark Conklin, but there. So M17 is the preferred Wordle size. They do 7 by 1, which if you do Wordle, that's kind of funny. It's by Mark Klein and Mark Conklin. As we know, they are brothers from different mothers. So. M17 is the register that causes the Yaesu FTM 400 processor to halt and catch fire. Try that. By the way, for those of you, how many people know what halt and catch fire means? It was a magic instruction that would cause a processor to heat up and then eventually catch on fire. And there's actually a series that was called halt and catch fire. Final answer is Moko Toska 17 is the club address for SP5KAB, which is the Warsaw, Poland Amateur Radio Club.
I'll buy that one.
Because the originator is a member of this club. So M17 is actually a street address. And a lot of you guys are like, oh, no, it's not a street over in Poland right there. What's he talking about in this thing? I actually did this originally, and a lot of people voted for the Mark World thing. They thought that was the way it came up because they think we're pretty famous around the world. So, that being said, before I get in deep into this, sources for M17 information, and this information, by the way, at the end of this presentation, actually, before we get too far, let me hand out a sheet with a pen, and please write your name down on it and pass it to the next person. Anyway, I'll be emailing to all of you guys this information, but the biggest place to go to is m17project.org. There's more information on there about M17 than any place else in the universe. Very centralized. It's really where all the discussions are occurring. There is an M17 Discord server, which allows you to do both video and text and send pictures and things of that sort. rcwa.org and the RCWA Facebook page. And of course my email address if all else fails and you're asking questions about how to get your M17 set up working, you need some hands-on, just send me an email, I'll help you out. So, let's switch on over here. There we are. So, this is the m17project.org website, and I'm going to go into some different locations on that website just to kind of give you an idea of what the information is out there and kind of give you an overview, a very high-level view of what M17 is. So, we figured out why it's called M17. Now let's figure out what is M17 and what actually started the work on M17.
Why don't you tell us what we're circulating here?
Sign up sheet right there. Put your name, call sign, and email address, please. So, M17, the reason it started was the originator, who's actually Polish, the gentleman that started this, was looking at a way to get a voice protocol that didn't require license fees, didn't require having special chips, all the stuff that we're used to having to deal with when we start talking DMR, AZ System Fusion, D-Star, and all of that. And if you go back several years, it's been an ongoing issue that whenever amateur radio got into doing voice modes in particular, we were always licensing technology from somebody to actually do the vocoder. And in some cases, that was a very expensive proposition. But at the very least, you gotta have a chip that is provided by the company to do the encoding and decoding of the information. And that's really great if you have a physical setup like this and the chip's built into it and it's all there and it's in one spot. It really is very difficult to implement once you go up to cloud-based servers and you're trying to do codes and decodes. And it's even harder to implement if you're trying to develop new hardware and things of that sort. You're doing it in very low quantities, and in some cases you may not be able to license the chip technology for quantities of 5 or 10. They typically start in the thousands. So as this has come along, it really came down to what can amateur radio do to better itself. A lot of the technologies that we were using previous to this in Yaesu System Fusion, DMR, D-Star, P25, NXDN, well, out of all those different technologies, DMR is a commercial technology that's been adapted for our use. Does a wonderful job of showing your call sign on there, and I say that tongue-in-cheek because we all have to get a 7-digit code to say who we are and be able to make that connection. So it doesn't do a real good job of IDing and things of that sort. It is also a fairly steeply learning curve to get your code plugged right for your radio. Then if you start talking P25, up until a few years ago, extremely expensive to get started with. And the radios were built for public safety. They really weren't developed for amateur radio. Then if you look at NXDN, same issue right there. So all the commercial protocols kind of being mapped on over. There's a little bit of a hard push there. Then, if you went back to the manufacturers for the commercial and said to them, hey, I'd like you to add a feature that, like, my club's call sign or whatever appears in the lower left-hand corner of this radio, and I'd like it to do certain things, maybe like, handle weather bulletins and stuff like that. If you talk to a DMR company, they would just kind of look at you and say, you're less than 1% of what we build as far as radios, because most of ours is commercial. You're not going to get somebody to suddenly make those technological evolutions. You do the same thing on P25, same thing on NXDN. If you go back to Yaesu System Fusion, curiously enough, there's been several of us that have asked for access to the internal data transfer protocols that are within Yaesu System Fusion, and Yaesu says, no, we really like to keep that closed to ourselves, and you use our equipment, our protocols, and our hardware. They keep it very much close to themselves because they view it as a competitive advantage to their equipment. D-Star was fairly open except for the vocoder, and by the way, the vocoder that's used on that is actually AMBI version 1, and it's kind of obsolete now, but we're kind of stuck with it because that's what they started with. Whereas AMBI version 2 is what's been used for DMR, Yaesu System Fusion, and everything else. So the point being is, you have a lot of traction to go to manufacturers and say, change it to make it amateur friendly. No, you do not. It's very difficult to get the various organizations to support amateur radio in a way that we would like to go. And then you start talking, hey, let's do voice over data, let's mix these all together, let's come up with whole new protocols, things of this sort, and everybody says that costs money, that takes time. So there has been a move afoot for many, many years about developing protocols within amateur radio that are open source, that manufacturers can pick up and go with, and allows us to innovate within the hobby. And actually, several years ago, the Codec 2 was the first jump in that area. It's kind of a funny story behind it. I wasn't aware of the full story until I read or watched a podcast last week, and the FreeDV software that actually originally started out used what was called the MELP encoder, and that was actually an encoder that was licensed by a variety of companies, and the bottom line was the author got in trouble because they didn't want to license it for amateur radio use, and he was trying to use it to further the hobby and everything else. So it's real that if you try to use things that have been developed by others, you're either going to end up paying license fees, or they may just not agree to license it to you. There's a lot of issues you can run into that become very difficult to try to innovate. So the author turned around and developed Codec 2, and his name is Roland, I believe is his last name. And basically he came up with an entire voice protocol from scratch called Codec 2, has mainly used it on the amateur radio HF frequencies, but several years later, as amateurs in Poland were looking to try to move this to VHF and UHF, they took that exact same codec and matched it with an on-air protocol as well, and that's what M17 became. So really, what this is the way amateur radio has always been, which is innovating, coming up with new technologies, hacking into things, trying to figure out how things work, and getting it to the next level. So this is really driven by a need to innovate within the hobby, and not sitting here and saying, well, we're going to wait till a manufacturer decides to come forward and give us something that they think we want as opposed to what we want. That being said, and jumping a little bit ahead into the presentation here, M17 didn't get a lot of attention because it was this small group of guys about 3 years ago. It was in 2019. We're working on this, and as we know, lots of people around the world work on things, and so that's it. Could have very easily fallen into oblivion. Nobody would have ever heard anything about it. As you guys know, the ARDC came into a lot of money about that time. They gained from selling some of the 44 subnet addresses that they had on the internet, because the ARDC actually was the caretaker of those addresses, and very astutely back in the 1980s reserved those addresses and found out that they were worth a lot of money as of now. I think they sold around 10-20% of the entire list, and the amount was on the order of about $200 million. So the bottom line is the ARDC got a huge amount of money, has started giving grants. In fact, the ARL is one of their grant programs, and you can apply and say, I would like to have a grant for a particular project. And I think the ARL grant program tops out somewhere around about $25,000, but there's also $2,000 and $6,000 and $10,000 grants along the way. But the bottom line is the ARDC took it upon themselves to identify things that could improve amateur radio, and that's kind of their mission. How do we get more people involved with the hobby? How do we get technologies out there so that people can do interesting things? You know, basis of trying to make amateur radio better. And they eventually awarded $250,000 to the M17 development team for the full development of the protocol. So when people ask, well, why are we looking at this? It's got a lot of financial backing. It's moving forward. There's been a lot of progress in the last 3 years. And we, in fact, are seeing implementation now on repeaters and in some hardware applications. It's still very, very early, very preliminary in the process. And I'll just say it flat out to the group here. There was actually I believe it's Ham Radio Now is the podcast, I believe that it's called. And if you listen to the one that just came out recently, the essence of the title of the podcast was an appliance operator interviews the M17 guys. And it was coming from a standpoint of appliance operator. And quite honestly, a lot of our hobby are people that just buy a radio, hit the button, and go. If that's all you want to do, then this is probably not going to be something, at least in this stage, that's going to be big for you, because it's a lot of tinkering, it's a lot of getting into stuff, it's a lot of experimentation. So if you are the type that just want it to come to you in a pretty package, open it up and run it, wait a few years, I'm sure things will come along right there. But if you're somebody that likes to really go in, get into the guts of the radio, get into the guts of the software, figure out what's going on with it, this is an awesome opportunity to be on the starting level for a brand new revolution in amateur radio. And I wouldn't say that lightly, other than the fact that it's very well funded. There is now, according to our brochure here, should say it correct, there are now 2,000 plus people that are currently contributing on the online community to this. So it's not a small, small sector of people. It has gained a lot of traction. So that being said, it's a voice and data protocol that's different than what we have with the other protocols that have been produced by Yaesu, DMR, Project 25, etc. But it is well funded and it is driven with amateur radio in mind. So things such as embedding call signs in transmissions are just a given. They're taken care of. Things such as call sign routing, which aren't an issue in commercial systems, they're fully supported within this protocol. So there's a lot of things that have been done that give us an opportunity to do things right. And at the same time, it's been integrated into some of the voice over internet protocol stuff that we have that we've been doing with what's called the multi-mode digital voice repeaters and things of that sort. So that being said, that's what M17 embodies, is a new race of technology. Now, I'll ask a question here. Does anybody know what TAPR stands for? T-A-P-R. Yeah, Tucson Amateur Packet Radio, right? How did they get that name? They worked on packet radio. Did they wait until packet radio had been totally developed many years later, and then they suddenly got involved with it and they became really popular because of that? No, they were at the grassroots. The first TNCs, terminal node controllers, came from them. They were very much boots on the ground to get things done. Any amateur radio organization that's of a technology base that you recognize the name to, like TAPR, got involved in the front end, not on the back end. There are some exceptions to it, but the reality is, if you want to be involved with something that has a namesake that's known there, you're going to get involved in the early adoption as opposed to waiting until the late adoption. Quite honestly and selfishly, if you want to be a leader in amateur radio, if you want to be somebody that others are looking to for guidance and trying to learn more about the hobby, you need to put yourself in an uncomfortable zone. If you're always comfortable all the time, and you're always doing what was done before, chances are you're going to keep doing what you're doing, which is fine. There are some people that just aren't cut out there. But if you're somebody who's looking to become a leader, maybe a club president, or maybe somebody high up within ARRL, if you're looking to be somebody that's taking it to the next level, this is where you start, is with something like this that's a technology-based project. So a lot of times people say, how can I get involved in amateur radio? Well, the guys over here that have been doing HF, they've been doing it for over 100 years. Where's there a spot for me? What am I going to be able to do that's different than anybody else? In some cases, it's kind of a realm that has been done many, many times, and the amount of innovation is somewhat reduced. Not to say there's not fun things in the hobby, but you're not going to sit there and work sideband on 20 meters and have everybody go, wow, you're an inventor. No, it's just not going to happen on the whole thing. But with this, you'll have the opportunity to be looked at as one of the developers, one of the innovators that's involved with it, which if you have an engineering or technician mind, this is a great opportunity to get involved in this type of stuff. So that being said, let me go over to the computer here. And I'll first hit the link that says getting started. Further over. Ooh, that has a bad contrast to it. Says, so you want to do M17? I want to get involved with the community however I can. There's a link to that. I want to understand how the M17 protocol works. I want to get started with hardware hacking. I want to get started with software development. I want to use M17 over the internet. I want to use M17 over the radio. So that's really the major areas that you can get involved with this. So the first thing that I'm going to click on things pop up. So there's actually, and it's in English and Polish, there's actually a GitHub. It's called M17 Project, M17 Education. You can go there and actually look at the educational materials that talk about what is M17, what does it mean to us. And in essence, it's going to talk about, hey, this is an open source protocol. This is something that you're not going to have proprietary interests trying to get involved with it, closing the ecosystem, so to speak. You're not going to be forced with something that's a standard that applies to everybody in the commercial sector trying to be mapped to the amateur sector. So check out that GitHub site when you get a chance. Oops. There we go. Who's the team? I'll grab my keyboard, don't allow me to scroll down with this. So there we are. So that's Wojciech, who's the founder and lead developer of this, the one that got it all started. He is located in Poland. He's located in Warsaw, Poland. But right alongside him is KC1AVW, who is Steve Miller. He decided to get out of the touring and the band stuff and now heavily into the amateur radio. Not the same Steve Miller, but we like to joke that on every so often. He's actually located in the Connecticut area, and he's really good at explaining these things in the words that you can understand. He does a lot of the website development, as well as writing a lot of the documents that are the protocol documents and making sure everybody's on the same page as far as the development goes. Mike, W2 FBI, software prototyping and development. Ed, he is the community manager and one of our primary net controls. Interestingly enough, everybody I talked to before is hardware-based, software-based, something of that sort. Ed is an ex-New York City detective. And he is just neat to talk to because he gives you a whole nother perspective on what this should be versus the rest of the people on the team. He looks at it from a user perspective. He looks at it from a hobbyist perspective. He was actually involved in quite a bit of IT support within the detective area, so he's not just totally technically, he's not totally out of the technical realm, but he's not deep into the protocol, deep in the specs, working on CPUs and things like that. Mathis over in Germany, he's doing the hardware development for a thing called the Module 17, M17 module. This is an example right here. I'm going to pass it around so you can take a closer look at it. What that is an actual module that does M17 modulation. It actually takes whatever you say on a microphone. There's a connection for 2 ports right there that you can connect a microphone to. You connect your microphone to it. It then encodes your transmission and puts it out over the air on your 9600 baud capable radio. So if you have a radio that has that little 6-pin, or in the case of Yaesu, now the 10-pin connector that they have on the back of the radio, if you have a radio of that sort, you can plug into it, you can do M17 on it. And so this is a module that's intended to allow you to take existing radios, plug into it, and operate an M17, because we recognize there's an installed base out there. Go ahead.
You just need the packet port, right?
That's right, just need the packet port to go there. If you're creative enough and you know where to get the discriminator audio and do direct drive of your audio that's unfiltered, you can do it with any radio. But the packet port just makes it a lot easier, that it's an easy plug and play to do. So. Other questions there?
Oh, lots, but you get, go ahead.
Okay, I'm sure. So that's the Module 17 development that's going on, which is really hardware based more than anything else. Rob, WX90, Doug, AD8DP, and Doug has been one of the software developers of DroidStar. DroidStar right now is the only client software that goes native M17 that you can have for your PC. For your Android phone, it is not available in iOS any longer, but it used to be for a short period of time. And it, because M17 is an open source protocol, instead of having to have if you've ever done any of the other digital modes off of a phone or off of a computer, you end up with these little USB dongles that have the chip based into it, or you need to connect to somebody on the internet that has those hanging off of their computer so they can do the vocoding for you. One way or another, it's a very clunky operation to do. Well, with DroidStar, M17 is just built straight into it. In fact, on KC5FM's phone, we set it up, went to M17, connected to a reflector, did a test, went right on through. So when all else fails, DroidStar is a great way to get started at a client basis via internet. So what I'm saying with that is either download the Android version, put it on your phone, or you can download the Windows version, which I have on my computer that's sitting in the back there, and you can pull it right on up and start playing with M17 today without anything else. It works with your sound card system and everything else. You connect into the M17 reflectors. There's many M17 reflectors that are already on the internet. Would you say over 100 easily, KC5FM, that we've got out there? The Oklahoma link has M17-OKL is our M17 reflector, and it's a really neat place to hang out. The neat thing about it is it cross-connects with our Yaesu System Fusion, with our DMR, with our D-Star, everything else. So you can talk to people that haven't even got on the M17 bandwagon yet. So the neat thing about it is people always ask, hey, if I'm doing something new and different, am I going to be the only person talking to myself? Yes, you will. No, just kidding. But no, you'll be able to get on the air there, and people that have DroidStar or other things on their phone will have the capability to talk to you in the different modes there. Tom, N7TAE, forgot to mention him there when I'm starting to talk about the reflectors. The MREF-D, which is the M17 reflectors, and I think he's also come up with a universal reflector since then. Tom, N7TAE, has come up with the reflector system that works for M17, and it works well. You can put it on a Raspberry Pi, you can put it on any Linux-based computer, you can put it up in the cloud like what we do, and it allows M17 protocol to be exchanged back and forth. He's really done a lot to get this thing off the ground. What you've seen happen with this protocol is the software part of it has really taken off faster than the hardware part, because hardware takes certain times to get circuit boards made, it takes a certain time to get manufactured, it takes some debugging to get involved, etc. Whereas the software part of it is really people getting creative, writing the software and going. And so the first step that happened with M17 was writing the software libraries that were going to drive all this. How are you going to encode the data using codec 2? What are your frames going to look like that are going out over the air? Make sure that they're correct. So once the software was done, then the reflectors and all these other things kind of fell into line. So the neat thing about it is, as it's moving forward, there's already internet-based support for this, even before the radios have really made it out into the wild. So it's not like once you get a radio, you're stuck and that's it. And until somebody else gets an M17 radio, you're talking to yourself. Instead, you're very much able to interact with the rest of the world. In the case of our repeater, the 440-435 repeater, you get your M17 set up there, you talk through the repeater, you go to our reflector is connected worldwide. You could very well be talking to people all around the world. Last Friday, if you listened into our repeater, you would have heard the M17 worldwide net. It's on M17-M17 Module C, and we actually carried the entire net in native M17 here in Claremore. So you have an opportunity. By the way, lead developer from Poland, he was on there talking to us and the whole thing. So you have a chance to rub elbows with the people who are really deep into the software development here and hardware. So that kind of gives you an idea of who the project team is, and that's just a few of the people. One of the other team members, I don't know if you guys know this gentleman by any chance. I'll throw a few of them that are out here. You've got Jonathan, G4KLX. Anybody recognize that? He's the one that wrote the MMDVM software that you use for any of your, if you've got a Pi-Star setup, you can thank Jonathan for writing the software for your Pi-Star setup. He's the guy that was the brains behind doing all that. Assis, Nicola, of course. Let's see, Tony, VK3JED. Remember him way back in the Echoing days when it first started right there. He's our Australian guy right there. Very helpful at testing this type of stuff. So Tony's been great on this particular project. Morgan, ON4MOD, always good to talk to him. He has always got good insight to what we're doing. And of course, we also had with us as part of the development team here, a gentleman out of Oklahoma City. If you happen to see the M17 table that was here, Mark is part of the development team as well, and he's part of giving the feedback and the things that they're doing. He's been involved in a lot of the teleconferences about the open source HT project, which is really the first hardware project to make a fully self-contained radio. So a lot of stuff going on with this, a lot of development teams, great opportunity to get involved with it, but you're not going to be the only person involved with it. There's a lot of people involved in the community really pushing this thing forward. And like I said, $250,000 backing it up, which covers travel to and from conferences. They do a lot of going to Hamfest, things like that, to talk about M17. There's also costs for web hosting and things like that that need to be covered. There's a laboratory that's actually being put together up in Connecticut. They'll have test equipment and everything else to go with it. So if you're developing an M17 radio and you're like, yeah, I need to do some testing of the end result, you'll have the access to the full test laboratory out there. So there's a lot of things going on to allow people that are developing the things that go into M17 to have adequate support to be able to do it, rather than having to buy all the equipment on their own and go from there. Let me go back here. Hopefully, yeah, that came out. Ooh, went dark on me there. So, on the hardware side, we'll talk hardware first, software next. Module 17. It's a smart microphone module. If you guys remember from Packet Radio, the mic encoders and things like that were very much in fashion back in the day, this is kind of the mic encoder concept except for digitizing voice. So the idea is a smart microphone module that plugs into existing 9600 baud capable radios, such as your Kenwood V71 or your D710. Let's see, the Motorola CDM product line. Works great on the FTM 6000. That's what I personally use for all of our stuff. That's a newer class radio that Yaesu just came out that actually doesn't have any digital built into it. It's strictly an analog radio, but it has a 9600 baud packet port right at the back of it, and it does a great job with that. In addition to Module 17, there is the ADF 7021 module, and that's the module, or the chip that you typically see used in the hotspots. Very low power, not necessarily spectrally really clean, but if you're operating the milliwatt level, you're not going to interfere with others. So there's work going on with the ADF 7021, the Nucleo TNC, TNC 3 by MobileLink, supports the M17 protocol, and in fact, they just released the TNC 4 by MobileLink, which has M17 built into it native. It's actually the first commercial product to come straight out of the door with M17 built into it. So all you need to do with a MobileLink TNC 4 is take your Android phone, connect to it, and then you can sit there and start operating today. That happened within the last month. There's the Open RTX. Why is that important? The Open RTX, they're actually taking existing hardware, and the MD380 and MD390 seem to be the majority of their focus. You take existing hardware, which is DMR based, you make some small hardware changes to it where you go in and work on it. And when I say small hardware changes, these are tiny hardware changes. It's everything's surface mounted. It's kind of difficult to go through. But you just need to break a few connections, make a few connections, and that drives the audio properly through so that the CPU can deal with it. Bottom line is, you modify your MD380, and then you put a new firmware in it, and now it does M17. So you actually have a handheld that will run on M17. So hardware based, that's what's going on today. Each of those are fluid projects. There's new firmware that's put out for each of those. There's new hardware concepts that are put out from time to time as they try things and go, well, we want to make the audio sound a little bit better. Hey, we're going to change this, we're going to do that. So it is a moving target. It's not something that just stays static because it's brand new. But those are the main hardware platforms everybody's working with. If you happen to have, and I brought one with me today, this is a Raspberry Pi running a Repeater Builder's MDVM board. Some of you bought this to run to a radio. There's also MDVM hats that have the radio built into them, so they're what you use typically for what's called a Pi Star hotspot. These can be reflashed in the firmware in the actual board itself, which is the hat. That can be reflashed to support M17, and then you go to what's called the W0CHP fork of Pi Star, and it's where he's actually gone off and redone the entire web side of that. And you go in there and you have a whole new dashboard to work with. But more importantly, it actually downloads a version of MDVM host that has M17 support built into it, so it talks to the new firmware that's on your control board. This is actually the backup board to the 44435 repeater, and I tested it thoroughly for about a month there to make sure that we didn't have any stability issues before we rolled out to the main repeater. But with this, I can connect into my radio right here, the FTM 6000, and say, okay, let's start doing M17 on this. So it's that easy. So even if you don't get into the M17 module, even if you don't get into some of the other projects, right now today, commercially available, there's a bunch of these Pi Star hats that are available, a bunch of these MDVM boards. You can buy them on Amazon and every place else. You go in, you reflash the firmware, you go in, run the W0CHP dashboard, you're on the air, you're ready to go. So it's definitely a way to get on there quickly. start playing around with this. There is also, if you have one of these boards, there's also another piece of software called M17 Client that also works very well with it. And the M17 Client allows you to transmit directly on the board just as if you were operating the radio. So not only can you go and connect to the internet like you normally would with an MMDVM host, but you can turn around and actually transmit out on the airwaves just like a regular radio would. So that's been something a lot of people have played around with and had a good time with. How am I doing for time? Well, what time is it right now?
107.
107. Huh?
You have the rest of the day.
That's right, have the rest of the day, that's right.
I think they have testing here 1:30.
Yes. All right.
You're testing here 13:30.
That's correct. Yeah. The rotating deal on the internet here.
The wall is slow.
There it goes. So, like I talked about a little bit earlier there, got a little bit ahead of myself on this. On the software side, if you've got hotspots, there is the WPSD, which is the Custom Enhanced Pi-Star Dashboard by W0CHP. The reason I show this is if you don't remember what I told you today, you know where to go to, the M17 project website, and look under software, and it'll tell you exactly where to go. There's also the ALESO IU5BON that are some scripts that are used to update the classic Pi-Star to include M17. Personal preference, I prefer the W0CHP. It's just a little bit more polished product, but you can get more than one way to there. As far as the software clients themselves, you have Mvoice. So with Mvoice, if you put that on a Linux box, whether it be your Raspberry Pi or your Linux PC or anything of that sort, or your local community supercomputer, just kidding. If you do that, they will kick you off immediately. But Mvoice allows you just to put on a headset and talk to the reflectors directly. So if you're just trying to get started and you're not even to the hardware side yet, but you want to talk to your friends that are on M17, Mvoice is a very good software to get there. Runs on a Linux package. There is MREFD. So now you get to the point you're like, hey, I'm pretty cool. All my friends know that. I'm an amateur radio operator by definition. People are snickering when I say that. You know, like when you tell people you're a ham operator, they don't think you're cool. Trust me, they will in a few years. But anyway, MREFD, you suddenly now want to open your own reflector and have other people talking to you. So you can go ahead and host it on a Raspberry Pi, PC, out in the cloud, whatever. So MREFD is a big piece of software that's here. OpenRTX is the firmware that goes into the DMR radios. And there's development occurring on that as we speak. So that's an actual firmware that loads onto those DMR radios. It's totally open source. And the neat thing about it is, and I issue this as a challenge, if there's something you see on it that really annoys you and you don't like, learn how to program it. Make the change, recompile it. Guess what? You can exactly make the thing the way you want to do it. And I've done that a few times with some of this stuff. Hey, this is really what I want to add. I want to put a few more buttons on it. I want to do a few more things with it. That's the great thing about open source is you can make it anything that you want to do. And by the way, if you think you want to share it with some others, this stuff's on GitHub. You go up there and turn it as a change, and if they accept the change, then your change now becomes part of the main software. DroidStar, we talked about there. DroidStar supports M17, so if you can load it on your PC or load it on your Android phone, you're online immediately there. MMDVM. I was talking about, what runs our Pi-Star and everything, the MMDVM host. It now supports that. What else we got here? The MMDVM _HS. If you guys aren't aware of this, the G4 KLX MMDVM is written for boards like this that go to a radio. When you have the boards that have the radio built into it, it's actually MMDVM HS, and that's actually done by Andy CA6JAU supports that. In a similar way, you recompile that, put that firmware on your hotspot and go. You need to know which one that you're running so that you don't put the wrong firmware on the wrong board, because then you won't get the features that go with it. M17 client, we talked about that. It's a pure M17 protocol implementation that goes directly to the MMDVM modem, and you're talking on the air. You're talking on true M17. And as far as I know, I believe M17 client was the first software that went out there. Don't quote me on that. By the way, you're not stuck strictly with all the things we talked about hardware-wise. There's also SDR support, software-defined radios. And did anybody that's here get a chance to go to my software-defined radio presentation that I did a while back? Nobody? Okay. I'll keep that in mind when I'm covering things here. Yes, I did. Yes, I did record it. Okay. So software-defined radio. Where did I set my software-defined radio stuff down? Oh, it's right back here. It's right back here. So, and where are we sitting at as far as time?
113.
Was it 113?
Yep.
Yes, sir.
Exactly where I wanted to be at this time. This is a hacked RF1 SDR, and SDR stands for software defined radio. Why is it called a software defined radio? Well, in the most purest way, and this deviates slightly from that, but in the most purest way, you have an analog digital and digital analog converters that are on the board. So what they essentially do is they just take whatever's occurring in the RF environment, and you sample it through the analog digital converter, and then the software does all of the logic to figure out, how do I translate it to make sound out of it? How do I translate it to make pictures out of it? How do I translate it to make, in this case, digital voice? All that's done by the software-defined radio. This is a perfect candidate because it's a dumb piece of hardware otherwise. It's not like it knows sideband. It's not like it knows AM, anything like that. But then you load the software on your laptop, and SDR++, SDR Angel, all have M17 coders and decoders built into the software. So the neat thing with that, and what I've actually played with this, is I actually load up SDR Angel, and I plug this on in, and this has the ability to transmit. So I actually sit there and transmit M17, and then I turn and grab another SDR that I've got, put it on the other USB port, and then I sit there and receive myself and actually translate my M17 packets. So that's a way to get started that requires no investment above the original hardware that many of you guys have these SDRs. You don't necessarily have to go with the fancy ones like this. Even just on receive, you can use what are called the RTL SDRs, which are the old radio, or old television tuner, little USB sticks that were built in the millions out there, and eventually people converted them over and plugged them into the computer and said, oh wow, I can see things going on in the public safety bands, and then they eventually down convert them. Oh wow, I can see HF going on in these things. You can take those exact same RTL SDRs, punch them into the SDR++ software or SDR Angel, say, hey, I want to listen to M17, get it tuned in, and you'll hear it directly over the airwaves. So a lot of opportunity there in terms of the software-defined radio platforms to get involved with this. So about where I wanted to be in this presentation, up here in the front, for those of you that are interested, I have some RCWA literature right here, just benefits of joining the club and being involved, and one of them is the fact that you're going to be involved with a lot of this M17 stuff. I also have a handout over here that actually talks about M17 in general, and then we couldn't resist M17 stickers for everybody. Put these on your refrigerator, your car, everywhere that you go right there so that people know that you're with M17. And the funny thing about it is that they all look at you and they go, you're so cool. It was so cool. It hasn't quite worked with my daughter yet. She just sits there and goes, pass, and that's it. I lose on that one. But I hope that gave you a very good idea of why we're doing this, where we're moving forward. I'll be quite honest about it. It's in the early part of the project, so there's a lot to be done with it. The 44435 repeater that is in Claremore, we are, according to the repeater book, we are the third repeater in the United States to go on the air with M17. And one of the repeaters is actually KC1 AVWs, which is kind of cheating because he's been involved since day one on this. So he has a vested interest to have that on the air, but the reality is, if you go west of the Mississippi River, we are the only M17 capable repeater that I'm aware of. There may be some out there that haven't registered with the repeater book yet, but I'm not aware of anybody else out there that is doing M17 with their repeaters. So we're cutting edge. We're putting Tulsa on the map right here. So hopefully the other side that I ask that you guys be able to do is if we put this stuff on the air, support it. Get out here and start playing around with your SDR, start playing around with your hotspots. Get involved with this because this is going to be a lot of fun. And so that's the part that I can ask from there. Go ahead, Greg.
So, question, if you've already got a DMR digital hotspot and you wanted to add M17 as a network where you plug it in, you're using it in a multiple modes.
Multi-mode.
Have they already defined the section that you need to plug into the network config on your Pi-Star?
Yes.
In order to be able to do that?
Yeah, that W0CHP dashboard actually has a line that shows you exactly how to get there. It says M17 protocol, turn it on, and you go and put all your configuration into it.
Okay, so you could add that into an existing DMR hotspot, so
Yes.
you still got
Yeah, as long
DMR
as it's,
P25,
Yes.
you know.
as long as it's a Pi-Star type setup, you
Yeah.
can add it right on in there.
Okay, got
And
it.
I'll provide assistance to anybody as far as recompiling and stuff is concerned, because I've learned a few of the tricks going along the way there, how to recompile the most effectively. And, but yeah, it's exactly that. You can take existing hotspots and convert them over very easy. Really out of spot right here for questions. I usually put a little bit more time in the presentation for questions, but this one had a lot of material to cover. And what I want you to walk away from is, first of all, go to m17project.org. That's really a place to get immersed in this. The other thing is, where are they available as far as texting and talking and video is concerned? What platform are they on? Anybody know? Discord. You'll find it if you go to their website, but Discord's where everybody hangs out there. And you'll literally see all times of the day and night messages going back and forth. I made the mistake on Discord saying, here, send all of my notices for these groups all the time. I'm sitting at 3 o'clock in the morning, bing, 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 going off there. I was like, okay, off. Don't do that again on the whole thing. But you got guys from Europe that kick on in, guys from Asia that kick in. You got people from North. It was funny about it is the bing, bing, bing one night that was going off was the guys from North America that were hitting it there. They're like, oh, I'm trying this now. It's great, and everything. So no guarantee it's always Europe that is staying up late and doing the stuff.
So question about your radio specifically there you're using.
Yes,
Tell me more about, you said it's a Yaesu,
FTM 6000.
okay, and it's got, what is the interface port that you're using on the back of it to interface with the
Yeah.
other?
What it is right on the back of this where you see where this black plug goes into here. I'm gonna
Yeah.
pull it out.
Yeah,
This is a 10-pin, because they went to 10 pins with all the
10-pin
later
DIN
ones.
plug, yeah.
This is a 10-pin DIN plug, which has a 9600 baud, pin out to it.
okay. Perfect.
And so any of the radios that have that, like even the old FTM 7900s, I believe it is, 7800s, all those ones that are the dual banders, have that 9600 baud pin out on them. Some of the ICOM rigs do as well. Some of the I would say the ones that are over 5 years old, because they kind of got rid of it in later sessions. Kenwood has it on a lot of their radios, like the TM D7s and what have you. There have it. There's just a lot of radios that have that capability.
But that port's separate than like some of the other radios that have a USB port built into them, correct?
That's correct. Yeah, in fact, just to caution everybody, even if you have a sound card built into your radio, which some of the ICOMs do, that sound card does not have enough dynamic range to be able to do this type of work. So when we start doing wide bandwidth, the entire bandwidth of M17 is about 9 kilohertz, which normal audio bandwidth is about 3,000, 4,500 kilohertz. So, or hertz, 3.5 or 3 to 4.5 kilohertz. You're going to be about half the bandwidth that you need to be able to modulate M17 effectively. So the USB type connectors ones will never be able to get you to a point where you can do this. But if you have a pin on the back that does the six pin configuration, you're in there, you can start playing around with it and having a good time.
The packet port on the 817, that'd be okay.
Yes, in fact, it does work. If you go deeper into the website, and I didn't want to bore everybody with the details today, if you go deeper in the website, it actually lists which radios have been tested and which ones have worked with what they're doing there. Other questions?
Jeff, is that M17 board you passed around a while ago, is that currently available?
It is currently available as in on their website, it's on a GitHub, it has all the information with it. And they actually give you instructions of how to order that board. You can actually have a custom fabricator do it for you. And so you actually have a full bill of material, a full schematic, everything that you can send, the CAD files and all that information, but you still have to do it yourself. There's hope that once it gets to a point where it's pretty well set, what the group is hoping is now we publish this out here and some enterprising entrepreneur says, heck, yeah, I can make these things. The next thing you know, Zeus Manufacturing or whatever picks up on it and they build them in the hundreds and put them, bring them to Hamfest and sell them and everything else. I think we're probably reasonably 6 months to a year out from that, but it's gonna come pretty soon right there. When it does, it's gonna open up a lot of stuff for people to be able to play around with. Go ahead, Lloyd.
One of the benefits to M17 from my experience, and you mentioned Echolink. When Echolink first came out, it was audio-wise was trash. And I remember having an Echolink station in the EOC and being on Echolink on my Motorola flip phone, and the people back home couldn't hear me. This is in development.
Yeah.
The thing that I liked about M17 on the analog side, Hamshack Hotline has the best audio quality over All-Star.
Yes.
M17 on the digital side, my experience has been M17 has the best audio on the digital voice side.
Yes. And it's got a little bit wider bandwidth and it was really written to preserve audio quality. You have to realize on the commercial side, in a lot of cases, they're trying to narrow bandwidth as much as possible, get as many channels back together. So what drove DMR is different than what's driving this. We want to use a little bit more bandwidth to get the audio quality rather than sacrificing the audio quality. And I will say, as it's developed along, like any software, it has bugs in it. I got 1 minute, okay. Any software has bugs in it, and we've caught bugs and had things. The one thing that actually was talked about during the Ham Radio Now podcast that was interesting was how many people have experienced the dreaded R2-D2 that suddenly goes to a squeal on D-Star. All of a sudden you're hearing somebody, it goes whack, and makes that huge noise, and you're just like, oh wow, I didn't need that here today. That doesn't happen on M17, and that's by design. They made it so that if it doesn't have a data stream, it doesn't try to guess something that makes you deaf. And that's really living off of learning what we've done with D-Star and other modes and making it a better mode.
Oh, that squeal is a buffer influx?
Yeah, that's exactly what it is. And so it's always been an issue on D-Star. It even comes up on using System Fusion. But that little squeal, that whap squeal that kicks up there, you're just like, wow, that just hurt. I have yet to run into it on M17. Doesn't mean that it might not happen, but I think it's far reduced because the way that they take care of it is to kill the carrier rather than trying to make a guess and be wrong on it. So, time's up right here. If anybody has any other questions, thank you very much. Everybody signed in the sign-in sheet?
Yeah.
Okay. I've got M17 stickers up here. Grab a flyer.